Okay, next with our programming with JDBC, I want to talk about some best practices and some pros and cons. The best practices have been kind of well established over time. Do things like put connection information in a configuration file. So when I was showing you that code with the URL, username, and password, like I mentioned there, you typically are not going to put that kind of information directly in code. You're going to put it in some kind of configuration file, a Java properties file, an XML file. A lot of folks would use something called a Jindy namespace to connect to a data source. We're not going to go through that level at this point. A lot of times your container of an application, particularly if you're writing a web service or a web application, will provide the credentials for you, so you as a developer don't have to maintain them. But it's a security risk to put connection information directly in source code, obviously, as well as the need to recompile and redeploy your code. Use a connection pool. So we were talking about those connection objects representing a socket connection. A connection-oriented socket is going to have a longer setup and teardown time than a connectionless one, like an HTTP connection. So instead of opening and closing a connection for each individual query, you can actually pre-open connection objects and then hold on to them in a global object inside your application, and then just go and ask that global object to use an already existing open connection so you can avoid that network setup and teardown. Don't string concatenate parameterized queries, or any kind of queries really. When you string concatenate, you are opening yourself up to kind of security risks. So again, if you're string concatenating as a way to parameterize your queries, use a prepared statement instead. Handle all SQL exceptions locally. That try-catch block, right? The sample code just print it out to stack trace. In reality, you want to take whatever action you can to translate that SQL exception into a retry or something else. Now, if the queries just won't go through even after a retry, then you do have to return something back out to your parent application to let it know it failed. Usually what you do is you convert the SQL exception into your own client-facing exception. The reason why is we don't want to put JDBC code all over our code everywhere, because that's intrusive, right? If we decide we don't want to use JDBC later, maybe we switch from a relational database to a MongoDB and NoSQL. I would have to take, that doesn't talk JDBC. It talks a different driver language, and I'd have to pull out all that JDBC code. So the real point with number 4 is it's part of, let's keep all our JDBC code kind of in the same place, factored in the same place, in case I want to switch the nature of my persistence service in the back end for my application. I don't have to go hunting through my code for all these exceptions, for all the select statements and all this kind of stuff. So, we haven't gotten into code structure. We're showing pretty simple, direct examples of just talking JDBC in a main program. But in a larger application, you would want to factor and put that behind some local interfaces in your application so that you could get rid of that JDBC code if you needed to. Try to avoid proprietary JDBC driver extensions. I'm sorry, I skipped one. Use higher type drivers, and I mentioned that before, type 4 being the best. So when you look at them at 4 down through 2 really, if you can get a type 4 one, use it. But again, a lot of times those things are sold. They aren't for free because there's a substantial amount of work that the vendor put into those things. But usually you can get a type 2 or type 3 driver for free, and certainly that'll be sufficient for this class. And again, in those drivers, avoid the proprietary extensions. So all those drivers do conform to the JDBC specification. You can use all the code that I was talking about here. All the code that you have, sample code, would work against any JDBC compliant driver. I've tested them on Apache Derby, MySQL, Postgres, all these kinds of things. But each driver, if you read its documentation, will try and convince you that it has more efficient proprietary extensions. But once you do that, you're going against the need to use a standardized interface in the first place, right? You're now locked into a particular extension from a proprietary vendor. But if you have to, right, if that efficiency is just worth it to you, then again, try and factor that code into some kind of subclass or delegated class so that you can get rid of that proprietary extension if you need to in the future. Make sure you close all connections, and really all resources, but I emphasize that the connections are most important, in a finally block to guarantee that the close operation does get executed, whether you execute that method, whether you exit that method with success or via failure, or meaning an exception is thrown. Even if that exception is thrown, connection.close will still get executed. Use prepared statement for any popular queries. Queries are going to be executed a number of different times with different parameterizations and should be in the query cache on the server. Go ahead and use a prepared statement. Try to avoid select star. Select star, try to be intentional about what data you expect back from the database. Otherwise, particularly if you use select star and you use, and again, I did this in the sample code, you see select star and then you see get by column number. Well, what if the database schema changes, right? So the best practice is actually name the columns that you want to do the select on, and then in the results set dot get string, get int, whatever, instead of using numbers there, get them by name. All right, so I did a get string 1, a get int 2. But if I knew that the first parameter column name was name, I could do a get string parentheses string name. All right, it's overloaded to take that parameter type, and that's actually a better practice. What are some of the pros and cons of working with JDBC? Some pros. Now, first is like I just said, you can remove all this proprietary database code. You can do some pass-through on some specific syntax, particularly SQL extensions, but really you have no proprietary database code embedded in your code, and all the other ones before XOpen CLI bound APIs had some kind of proprietary extension in them. So you don't have to rely on a single vendor because of that. You can, unless you do some kind of weird thing with some kind of extension, at least that code will port. So like I said, even a sample code for this class, you can use any number of databases and it'll all work, and that's part of that standard interface part. Realize though that not all the drivers are created equal, so there's still an efficiency aspect and a security aspect associated with which driver you select, which database you select, but at least the code shouldn't have to change. And therefore you don't have to make the database vendor decision early. If you're developing this way, maybe you are using an open source Apache Derby local database kind of thing, and maybe you move up to a MySQL Postgres, maybe eventually you move up to a commercial offering like Oracle, but you can start out on your developer boxes prototyping, writing code against JDBC, and you don't have to worry about changing that code later. All right? It's also easier for database vendors, right? They don't need to provide a query language to different languages for different applications. It just, it says, just give me, if they implement a driver with that API, they don't have to provide their own support. And again, JDBC is more of a tool vendor API to start with. A lot of frameworks are written with JDBC underneath. You won't write typically your own JDBC, but again, we're showing you how it works in this class, but it provides that kind of low-level support. You can see the abstractions of things like, connection represents a socket, a statement represents a query running on the database server, a result set represents a cursor on a database server. The JDBC API is a very direct representation of server-side objects represented in your client code. What are some of the cons? All right. Vendor-specific issues often arise anyway. JDBC tries to get rid of them, but still kind of happens, and you still wind up doing a lot of factoring in your code to try and avoid vendor-specific proprietary extensions getting in the wrong place and making your code not maintainable. SQL is embedded in the source code, as we've seen. Now, there's different ways we're going to talk about dealing with that, but you can remember, the SQL code's not, SQL is not going to be compiled by your Java, right? When you run Java-C on it, that string is still in there. So if you have a problem with your SQL query, your SQL syntax, you're going to find that at runtime. You're not going to find it via the compiler, all right? It doesn't abstract persistence. It abstracts system structures, meaning, again, literally the API, connection, statement, result set are server-side objects, which means you still have to understand a lot. To use JDBC effectively, you have to understand a lot about how a database works and the server works. So you're not providing really what's called a persistence API, an abstract, hey, I've got an object or an object graph like serialization. I just want to persist it and I want an API to do that. You've actually got to write all the persistence on top of this low-level plumbing API. And then the code becomes very verbose. I mean, looking at what we did just to query and iterate through a result set in a row, we had try catch blocks, finally blocks, we had setup of these different system objects. So the code becomes long. That's what verbose means. There's a lot of it. And the API is very intrusive. The JDBC API, if you use it directly, it's very difficult. You have to be very good with your design patterns and your coding practices to avoid JDBC bleed all over your code. And again, intrusive means just that. It winds up everywhere in your code, and then you wind up with this low-level plumbing code that doesn't have anything to do with the value of the app and is very difficult to maintain, especially if you decide to get off a relational database and move away from JDBC and go into something else. You pretty much render your code useless and have to start over again. All right. So again, you rarely code against a database using a low-level API like JDBC. It's largely for tool vendors. But we're doing it here because we really want you to understand how the plumbing works and how server-side abstractions are represented in client code. And when you go use a framework, you'll have an understanding what that framework must be talking to underneath the hood and what's going on. Because eventually something's got to go over the wire and come back. There's no magic there. And all that most frameworks do that you might program against is actually have JDBC underneath the hood that it's talking to, and it's trying to optimize. And some frameworks aren't all that great at that, by the way, so it's useful to know the plumbing in case you get in a situation with production where you've kind of got some code that's poorly performing. All right. What are some of the issues for software developers? And I've started a couple of these because I'm going to do a couple drill downs. But the general issues. The first issue is a set of impedance mismatch issues, what I like to call them. Impedance, kind of things that don't fit, right? Square peg, round hole kind of stuff is really what I'm talking about with impedance mismatch. The first is that we're in an object-oriented language like Java, but we're going to and from a flat relational model, right? In object-oriented terms, we like to think of an object with all its data and all its operations in one place. That's what the principle of encapsulation is, right? But in a database, this one object might be, 3 rows and 3 different tables that are represented by foreign keys and have to be joined together, all right? Because this model over here on the relational side, this is flat, right? And this is, well, it's not flat, right? We may have subclass relationships going on there, and we are working in this encapsulated fashion, not having our data spread out in that way. Another impedance mismatch is transactions. Again, transactions are kind of contrary to the notion of encapsulation, meaning each object has its own encapsulated data, and you have information hiding, meaning you don't have to expose what the object actually stores. But in a relational model, that's kind of wide open. The second thing is with transaction is we'll kind of find when we're going through object-oriented code, normally you have a conversation with the object, and each object makes its own state change on its own and its own cadence, if you will, its own rhythm. Whereas again, transactions are more efficient when executed at scale, together, if you will. And then connection-oriented semantics of sockets, right? That connection stays open, and we have to be very aware in our application that connection remains open. If we forget about it, we have a resource leak. We're kind of more used to working in a connectionless fashion, which means the connection opens, I execute one operation, I get a result back, and I'm done. Right? That's how web application development works. That's our preferred mode usually as an application developer dealing with sockets. So that way we don't have those resource leaks automatically. But again, that's not what JDBC does by default. We have some concerns that I call software engineering concerns. Things like, how do you keep database access secure? Now you have all these client programs running around out there, and they may have username, password credentials like we saw that had to be given to the driver, right? The best way to do security in general is to make sure your organization has good, well-defined security policies and those are enforced. So one policy might be don't share the production credentials with the dev team. Don't let them on the production database server at all. Use different credentials and different levels of access in different staging environments, development versus QA versus performance tests and so forth. And that takes some rigor to do. It's very tempting when you're troubleshooting a problem to have all these credentials flying around all over the place. So different policies. And then databases on the server have their own security standards, if you will, part of SQL. I mean, have you implemented role-based access and the proper grant permission statements on different database entities, all right? Because if you've done that, if the client comes in and tries to execute something over JDBC that it's not allowed to execute if it were sitting on the server, then the server is going to refuse it anyway from the driver, and you're going to get one of those SQL exceptions back related to security. How do you validate SQL in your code when it's not compiled? Like we talked about, you have all this embedded SQL running around in strings. How do you validate that when you run the compiler and it doesn't help you? Usually you have to do extensive unit tests. You have an angry DBA that is watching all the queries that you put in the code, usually helping you write them anyway. You can also have frameworks help you out with this, as I'll show you in one of the drill downs. Then how do you optimize performance? All right. You have to optimize the queries that are executing. Prepared statements, we talked about the query cache. That's just one optimization. Fetch sizes, we talked about. Fetch sizes are another optimization, right? How much data are you grabbing for each network hit? because you want to reduce that network latency. How do we put a lot of queries together? Queries are always more efficient executed in one transaction. I mean, if I had to update 10 different rows of a table, if I do 10 individual updates statements and execute them in one transaction, that's going to be less efficient than putting those 10 updates in a single transaction and executing them all at once. And again, from an object-oriented perspective, that's not actually naturally how we think. So how do we kind of bring in that and address that transaction impedance mismatch in order to get more efficient communication over the network? Pooling connections I talked about briefly, right? Since our connections stay open, let's keep a pool of already open network connections so we avoid network setup and teardown. The use of caching at the object level so you don't avoid redundant queries. Using stored procedures, again, things I'm going to talk about in the drill down. How do you demarcate? I mean, how do you indicate where the beginning and end of transactions are? And again, this is related to our impedance mismatch as well. Frameworks are going to try and do this for you. Frameworks actually try and use aspect-oriented or injection type patterns to understand where a transaction should begin and end and try and make it a configuration problem, not a programming problem, if you will. How do you deal with that first impedance mismatch? There's different solutions for that. We're going to do a drill down on that as well with object relational mapping and SQL wrapping, as it's called. And then how do you manage use of proprietary extensions? And the answer is very carefully, right? Good use of design patterning, factoring the code in the right place to make sure it's maintainable, using a source control repository to make sure different branches are tagged with different proprietary extensions so you know where these things are in case, again, you have to go and port your code to another database or even off of JDBC altogether. All right, so that's just an example of some of the concerns. I'm going to do drill downs to talk a bit more about performance and impedance mismatch 1, how you deal with the object-oriented to flat relational data model problem. There'll be drill downs, they'll still be fairly high level, but just give you an idea of some of the detailed issues that come up when you're working with databases and application code.